Okay, so as I said last time, we will, yeah, as I said last time, we're gonna continue this and we're gonna solve even more harder questions. So let's get straight into it. And also, I made some corrections. Now this is quadratics instead of factorizing, because it wasn't factorizing questions, it was like more quadratic questions. Okay, so this is a question 1 which you did last time. This, if you want to review it. Question 2, question 3, question 4, yeah. Question numbers, yeah. And question 5, question 6. And this is where I left you. So, but yeah, it was a challenge last time to solve this question. And we're going to solve it right now, just to see if you guys are correct. So, let me just erase this thing over here. It's not erasing for some reason. So, let's just solve it without caring about this. Yeah, actually, like and subscribe, you have to do that. I have actually intentionally left it there. Okay, so x squared plus 6x minus 27 divided by 2x minus 5 equals 11. Okay, so we know x squared plus 6x minus 27 divided by 2x minus 5 equals 11. Okay, we can do the same thing we did last time. We can just bring this over here. Basically multiply both sides by 2x minus 5, and then we get x squared plus 6x minus 27 equals 11 times 2x minus 5. And then we can further simplify it. So, this is equals 11 times 2, which is 22, x minus 55. Okay, we have two equations in a line, no fractions at all. And you know what to do now. So x squared plus, not x cubed, I mean x, no, x squared plus 6x minus 22x minus 27 plus 55 equals 0. And then therefore x squared, whatever this simplifies to and whatever this simplifies to. Okay, so 6x minus 22. What is 6x minus 22? Well, it is negative 14, negative 14, and then plus 55 minus 7. I don't trust my mental math in this, so I'm just going to do it using a calculator. Plus 28 equals, plus 28 equals 0. Okay, we have a quadratic in here. I think it's going to solve this quadratic. Hopefully there are no decimal solutions. I don't think there are. Maybe there are. Who cares? So, okay. So we know A equal to 1, B equals negative 14, C equals 28. Can we factorize this though? I don't think it's that hard. I'm not gonna. Let's see. Actually, we're gonna try to factorize it. Let's actually not factorize it. Let's solve it using a quadratic formula. So negative b plus minus root of b squared. So negative 14 squared minus 4ac divided by 2a. Okay, and therefore we can do that. 14 plus minus root 14 squared, as we all know, is 196. It is 196. So 14 squared equals 196. You know that. So 196 minus 4 times 28, which I don't know what it is. So 112. So 112 divided by 2. So if that in place, I'm just going to subtract 196 minus 112, which gives us 84. So that means, just draw a line over here, draw a wall, and therefore 14 plus or minus root of 84 divided by 2. And as you might see if you look closely, 84 is not a rootable number. Now, rootable is a word which I think I made up, but basically means a root of a number, it has like a, you know, like a number, like the root of a number is like part of an like they're integers, right? That's what a rootable number means. So like, but this is not a rootable number because, like, you know, like, I don't know, I don't know, it's not, I don't decide it. So root 84 actually equals 2 times root of 21. So 14 plus minus 2 times root of 21 divided by 2. Now, how did I find this 2 times root of 21? Well, actually not hard. So 84 equals root of 4 times the root of 21, because 4 times 21 is, well, 4. So yeah, so then we can find out that root 84 equals whatever this is times whatever this is. So we know it's 2 root 21 because root 4 equals 2. Okay, so you know that. So it's, yeah, you know that. And then we just divide both of it by 2. So let's equal 7 plus or minus root of 21. So therefore we have a solution. X equals 7 minus equals, oh yeah, minus 21 root 21, and 7 plus root, oh my, oh wait, yeah, 7 plus root 21, and these will equal around, let me just show you. So x equals to like 1 decimal place 11.6, and then like 2.4 2.41 something, yeah, something like that. So that's the answer to this one. The reason there was a challenge, I don't know, it's kind of not that hard, but actually the first problem, which has like decimal answers. So let's actually move on to the next question. Question number 5, question number 7. Oh, this is actually a tough question which I found. I actually want to leave this for the end, as this is actually going to be the like a question which actually challenges me because I haven't solved it yet, and I hope I actually do, because it'll be kind of embarrassing. So in the end, I will solve this question, I promise. Okay, so let's move on to question number 8. Okay, this is actually, these questions are actually more than tough questions. These are more of the tedious questions. So let's solve it. Let me just write the question down because this feels better. So 2x minus 3, or x minus 2 plus 3x plus 4 over 5x plus 2 equals 2. Okay, how do we tackle this? Okay, I have to think. You can't use trial and error, so yeah, I definitely do not use trial and error. So we just need to make this into one fraction so that we can like evaluate it. So I think the best thing to do right now is to make it into one fraction. So to do that, we'll just have to multiply everything by the denominator. So the denominator of this should be multiplied by both of these. The denominator of this shall be multiplied by both of these. So 2x minus 3 and 5x plus 2 divided by x minus 2, 5x plus 2. Do not cancel these out because that, oh, do not cancel these out because that's the main purpose of what we're doing this. So yeah, so plus, we can just do this once more. So 3x plus 4 times x minus 2, and then x minus 2 times 5x plus 2. Now you might observe like these are the same denominator, so we can add them. Like, we can actually just add them. So if we add them, we get 2x minus 3 and 5x plus 2 plus 3x plus 4 x minus 2 divided by x minus 2 5x plus 2. Okay, we have an equation. Okay, this is actually a pretty long question, I think. It's gonna take some time, so let's get into it. Okay, so the first thing which I see to do is I don't like fractions, so I'm gonna multiply both sides by this x minus 2 and 5x plus 2. Therefore, we do x minus 2 and 5x plus 2 times the fraction over here, so it's x minus 2 and 5x plus 2. Sorry, actually a bit smaller because we're taking too much of space. 5x plus 2, and then plus, that's a very bad plus sign, plus 3x plus 4, x minus 2, and then that equals 2 times x minus 2 and 5x plus 2. Phew. These two cancel out. All for nothing. Yeah. Oh, again. Okay. Yeah, so we get 2x minus 3 and then 5x plus 2 plus 3x plus 4 and x minus 2 equals 2 times x minus 2, 5x plus 2. We get that, okay? We just simplify this, we get this. So basically, this still equals this, okay, guys? Okay? This whole thing is the same as this. We're not doing anything weird. Okay, let me just erase this. But computer should know. Okay, wait. Let me just erase it. Oh, I'm the wrong button. Okay. Okay, let me just erase it. Okay, now we need to simplify this expression. So we're just gonna have to expand it. I don't think there's any weird technique we can use to do it. So we're just gonna have to expand it. Yeah, you have to expand it. Yeah, so we assume do the old ways. So 2x times 5x is 10x squared. 2x plus 2, that's 4. X minus 15x minus 6 plus whatever this thing is, so it's 3x squared plus 4x minus 6x minus 8 equals this thing, which is 2 times, oh my god, 2 times 5x squared. I'm just going to simplify this because we don't have much space. So plus minus 10x plus 2x is minus 8x minus 4. Oh, that was just fair. Okay. Okay, we have an equation over there. Okay, so we need to simplify this now. So let's simplify this over here. So this is a 10x squared, whatever this thing is and whatever this thing is. Okay. Maybe let's just add these, so it's plus 3x squared and minus 11x plus what is it? Negative 2x. Yeah, negative 2x. Let's hope it's that. Now go to 6 minus 8, which will be negative 14 equals this thing over here. So that's 10x squared minus 16x minus 8. Okay. Okay. Okay, let's simplify this furthermore. Negative 13x. If you like, such add both of them. The reason I'm not simplifying these is a reason which I'll tell you right now, because there's a 10x right over here and a 10x right over here. So we can just cancel them out. If you subtract both sides by 10x squared, just cancels it out. So we actually get a simpler equation over here. Like this. There's over here to just like draw an arrow. 3x squared minus 13x equals negative 16x minus 8. Okay, we have an equation. Simplified it, took a long time. So 3x squared minus 13x plus 16x plus 8. If we take this to this side and take this to this side, and then we can simplify this even further. So we get plus 3x, because negative 13 plus 16x equals 3x, hopefully, plus 8 equals 0. Phew. Okay, see you guys. Algebra is annoying, it's just annoying. We get 3 and we get 3 and we get... I'm just gonna factorize this, or should I not factorize it? Oh guys, I just realized that we actually can we find x? I'm pretty sure we cannot. The reason I said that we cannot is because I just realized that it plugged into a calculator that x actually is an imaginary number, so we'll just leave it like this. So this is the answer to the question. Sadly, x is imaginary for some reason. So let's just move. Oh wait. I forgot. Okay, so guys, mistake. Abort. Let me just erase all this. I made a mistake. I forgot something. Okay, I realized what I forgot. So it's not actually going to be imaginary. It's going to be a pretty good solution, maybe. So 3x squared minus 13x minus 14. I forgot that. Equals negative 16x minus 8. Now we just apply this equation. So 3x squared plus 3x plus 16 minus 13 equals 3. So minus 14 plus 8 equals 0. Therefore, 3x squared plus 3x minus 6 equals 0. We can simplify this expression, so we get x squared plus x minus 2. Everything times 3, because 3 is divisible by the equation, so equals 0. Therefore, x squared plus x minus 2 equals 0. I can factorize this, which is not that hard. So x plus 2 and x minus 1 equals 0. You can use a quadratic formula or whatever. X equals negative 2 and 1 using the rule. What rule is that? Well, the rule is, the rule is, when something equals 0, that means one of these things has to be 0. So we know that either x plus 2 equals 0 or x minus 1 equals 0. And we can just solve these equations. So therefore, x equals negative 2 and x equals 1. Yeah, so therefore, if you put in 1 minus 1 is 0, x plus 2 times 1, 0 equals 0, and then if you put in negative 2 plus 2 is 0, x minus 1, so it equals 0. So therefore, we know that x equals negative 2 and 1. I'm really sorry for the mistake. I will try to not do it next time. Okay, next question. Oh, yeah, this is going to be the end. Yeah, this is a bit of a tough question, or a mixture, I should say. Okay, so I'm planning to decorate a square of length A with smaller discs of radii 5 centimeters less than the length of a square. 5 centimeters less than the length of a square. Okay, somehow I know that there will be a total of 75 discs. Find A. It looks like find A to. No, it's actually find A to 2 decimal places. Okay, so basically I have like a square. From 8 centimeters of 8 centimeters. So this is square. Square has all sides of the same length. So we're going to decorate it with smaller. So the disc is like this. Okay, so disc is like this. Sorry for the bad circle drawing. So the radius of the disc is it was 5 centimeters less than the length of the square. So the length of the square was, is a, so length of the radius of this will be a minus 5. Okay, so that's the diagram. To find a to 2 decimal places, I know there will be 75 disks. So we can make an equation. So the area of this square will be, well, a squared, because as we learned in elementary, a times, this is the area, okay? And this is, I don't know, we learned in primary or something, a minus 5, the disk is a minus 5, it's a circle. So, we know that the radius is that, so we know that pi r squared is the area of the disk. So, therefore, pi of a minus 5 squared, therefore, pi of a squared minus 10a plus 25, therefore a squared pi or whatever minus 10 pi a plus 25 pi. Let's actually solve it over there on the answer page. Okay, so we know that the area is a squared and then divided by pi of a minus 5 squared. And we know that there will be a 75 disk. So like basically the reason I'm doing this is because, well, you have like small disk or whatever, like, and then all throughout the thing, you have small disk. So the amount of disks will always be like the total area of disk divided by the total area of disk. So that'll be like the amount of disks, right? So we can make this equation over here, and then we can solve for a. Because whenever there's an equation, one constant, you know what to do. Okay, so we can just solve it. So a squared equals 75 times pi times a minus 5 squared. If you multiply both sides by this, you get that. So therefore, a squared equals 75 pi times whatever this value is to. And as we know over here, whatever. Yeah, so a squared minus 5a minus 5a plus 25 is what this thing evaluates to. Therefore, a squared equals 75 pi times a squared minus 10a plus 25. And therefore, a squared equals 75 pi a squared minus 750 pi a plus 75 plus times 25, right? 75 times 25 is 1875. That's 1875 pi. That's a very big number. Let's hope that does not cause any problems. Okay, so we have that. Now we can just put the a to the other side so we can form a quadratic equation. So therefore, 0 equals 75 pi a squared minus a squared minus 750. Oh no, 750. Oh, it was a pi there, right? Pi a plus 1875 pi. Okay, so we have two a squares. We don't want to make it so that we have like a single constant next to the a squared. So we can just do 0 equals, we can factorize out the a squared, so we get 75 pi minus 1 times a squared minus 750 pi a plus 1875. This is a thing which you usually would not solve using like the like factoring or any other method which you do. There are only 3 methods, which are completing the square, factoring, and using the quadratic formula. These are the methods I know. I mean, you can use a graph, but that's just lame. So we can use a quadratic formula because that's beautiful. Okay. Now let me just erase all this because it's going to take some space. Oh no, I don't mean that. Okay. So now we have to put this in the quadratic formula. So we know that a equals 75 pi minus 1, b equals 750 pi, and do not forget the negative, do not, and then c equals 1875 pi. How do we know this? Well, we know that this thing, we know this thing, we know this thing. Okay, now we need to plug this into the quadratic formula. I'll draw a line over here. I'm going to change the color of my pen. You know, getting into the mood of solving this question. Okay, so we need the quadratic formula. What is a quadratic formula? Well, it's just negative b. I did not mean that. Okay, negative b plus minus root of b squared minus 4ac over 2a equals x. And therefore we can use this quadratic formula to solve for a. Oh yeah, by the way, I'm sorry for like this thing over here. This is actually a different a. So let's just make this a like let's make this like what do you call it, like f or something. Yeah, that sounds better. FBC. Okay, so I'm really sorry for that. It'll cause a bit of confusion, and that is actually not a. This is a different a, and this is a different a. So this is an f now. So yeah. So again, I did not mean that, but well, it just happening. I'm so sorry. So 750 pi. So we know that 7 negative b plus minus root of b squared. What is b squared going to be? Well, it's negative 750 pi squared. So 750 pi squared. Same thing. More root, yeah, minus 4a c f 4f c, yeah, 4f 75 pi divided all by 2 of f, yeah, 75 pi minus 1. Okay, we have an equation, and that everything x equals. Let's try and simplify this equation a bit. So for x equals, okay, this is a bad one. This is a very bad one. Okay, so 780 pi plus minus root 750 pi squared. What is 750 pi squared? 750 squared is 562,500 pi squared minus 4 times this thing. If you evaluate, that's 1875 times 75. 140625. 4 times 140625. Pi squared minus 1875 pi. Okay guys, so this is actually, don't get annoyed by this, this is different. Okay, so we know that. Then we know the bottom part, which is going to be 2 times 75, which is 150 pi, and 2 times 1 is minus 2. Phew. Okay, therefore x equals this thing over here. That's 780 pi plus minus roots, yeah, 562,500 pi squared. Yeah, times. Wait, what? 4 times 140,625 equals 562,500, guys. We're just start. 562,500 pi squared. Oh, minus. Oh, and yeah, it's actually plus because like negative times negative. 1875 plus times 4. So on 7500 pi. Oh, so this is x equals, these two cancel out because they're the same. Divided by, yeah, don't forget divided by 150 pi minus 2. So therefore the x equals, we need space, so we'll just transfer this thing over here. Therefore that equals x equals 780 pi plus minus root of 7500 pi. This is a monstrosity. Divided by 150 pi minus 2. Therefore, x equals, you can simplify this further. Well, I'm just too lazy to simplify this further. So I just do this. I'm just going to put my calculator. 7 pi. Wait. No. Okay, yeah. I'm going to put this in my calculator. Only just technical difficulties. Okay. 75 is pi minus 1. So we get 750 pi. 175. So we get the solutions x, which is actually not x. Oh my! a equals 5.34 something 35 something and 4.7 4.69. Yeah, 4.69. Yeah, it's a 2. Sorry, this video is a bit longer because I made a bunch of mistakes. Well, that's it. This is question 8. Question 10. I'm going to be solving this and the challenge question, which is this, in the next video. So this is going to be the next video, guys. Please. It's 2 questions, extremely tough questions, which I need to figure out how to solve. I will challenge you guys with this question right over here. The last question I need to figure out. Yeah, so I need to find x over a. Okay, find x over a. Next video, I will see if you guys can do it. And thanks for watching. Please like and subscribe. Yeah, please like and subscribe. See you next time.